Today, I'd like to talk a little bit about handling security incidents because we introduce right now the new ECIH course, EC Council Incident Handling course. This is an intensive 3-day course. The position on the development path of, in trainings on the EC Council map is like it is a higher level than CEH, but you should not think about it like a higher level of deep technical skills. It is rather the defensive approach to build proper rules, proper policies inside company, how to create teams, how to correlate tasks between them, how to handle complicated issues. So the half of this training is not technical, it's rather the approach to build a proper structure. Yeah. And today I'd like to emphasize a few things about incident handling. We will talk about a few steps. What should we do to build a team, incident handling team? What are requirements from experts' perspective? And then we will talk a little bit about incident handling related to malware threats. And malware attacks are the most common attacks against any enterprise, against any company right now. And to be prepared is a crucial thing. I like the one sentence from one of the famous NBA coach, which is, if you do not plan, you plan disaster. So if you do not prepare, you are preparing disaster. That's why we should we should have on the board teams, properly skilled people, procedures, because handling security incident in the chaos way will not work too well. And structured approach, when we have step-by-step process, already prepared forms, already prepared questions to witness of some security incident, then we can handle everything in much better way. Yes, so that's the goal of this course, to prepare us to build those processes. But that's the half of the course. The second half is much more technical, and we will have a lot of labs over there. Be familiar that there is also a few thousand pages. In 3 days, we will not cover it. So on many steps, you will be pointed to self-study, read this, read that. But it is like a good introduction yourself to handle such things. And one more important thing, consider approaching this course from your company size perspective, because we will cover on this course things like how many people should we hire for threat research, for security analysis, for reverse malware engineering, etc., etc. So you will see a huge map, and if you work for a company when all IT department is 2-3 person, you will feel that we are talking about completely different reality. So this course is focused or dedicated for huge companies. But if you work for small company, it doesn't mean that you spend all your life in small company. So if you have a possibility to approach this course and pass an exam, it can be great for your career. So I encourage you to attend this course, even if you work for a small company. If your IT department is 2-3 people and that's it, you still can build fundaments, some basic knowledge, how it can look like in a huge company, right? But let's go to our things related to this presentation. So what is security incident? We know that some things happen. In English, people say shit happen, yeah, bad thing happens, but not every bad thing that is related to our infrastructure is a security incident. So we have here some definition, but be aware that security incident doesn't have to be intentional. So it doesn't have to be always some kind of attack. But in most cases, it will be some kind of attack. You know that those days, the level of cybersecurity threats grow in such fast way. We should be on the top all the time. So handling this incident in efficient way, in a planned manner, helps organization to minimize the break in the business continuity, help the mitigate threats, help avoid some exploitation of vulnerabilities, and reduce risk. So reduce costs. Yeah, it's all about savings, right? And how to prepare for security incident. We have here suggestions step by step from EC Council, how it should look like. So first thing is to determine the need for all process. And in this part, we will analyze the business, the workflow. We will have to interview many employees about current security posture, about their approach to our business. The next step is building a vision. And building a vision and mission is just preparing documents with some goals. Yeah, what is the purpose of incident handling and response team? Then we should. The third step is the most difficult, I think, in many companies, because we have to achieve approves and founding. Yeah. In Polish reality, in small and medium companies, funding and budget for building such team is a really hard step. I worked for many companies but in my range there was a small and medium. Very seldom I interact with a huge enterprise. So in small and medium business, this will be the bottleneck. Yeah. So then, if we know the budget, if we can plan the scope of investment, then we have to develop and plan. And this plan for the team incident handling will have to have policies, procedures, will have to have the predicted training, predicted development paths, because people working in incident handling teams have to have a lot of skills, and those skills you are not able to Google everything. So in many cases, sending someone for courses, cybersecurity courses, for conferences like Black Hat, like incident handling response courses like CEH, etc. It's not cheap. Yeah. So according to the our vision to budget, we have to put it together, everything. And in the fifth step, we have to define incident handling criteria, and the sixth point is building team. So in the sixth step, we will deal with hiring new people, or maybe moving some our people in our IT departments to incident handling and response teams. So after building a team, we have to create a plan for our job, and we have to at the end we have to evaluate and update security posture of our company. And in ECIH course, we talk in detailed way about every step. But here I'd like to mention a few things about building a team, because as I mentioned before, this team is a group of technically skilled people, and they should be an experts. It's not like a junior IT specialist. Of course, junior IT specialist can be a part of this team, like on entry level in this team, but we have to have also experts, experts that are that have experience with, for example, handling events at full, handling evidence. So if, for example, some PC, some desktop is infected with ransomware, how to handle it? Should we turn off the desktop? Should we create some scripts to do something, etc.? When we deal with the people without experience, they will make a lot of mistakes with such issue, and maybe they will destroy a possibility to recover everything. That's why we have to have very skilled people. And at the first step, we have to create a plan, development plan, how people should learn, develop their skills, which one is going to direction related to malware analysis, deep dive in malware analysis requires in most cases knowledge about low-level languages, programming languages like assembler, yeah, because at the lowest level those kind of people will have to deassemble deassemble code. Yeah, if intruder is creating malicious code in some programming language and compile, at the end we will deal with a binary file, and this process is not fully revertible, so we cannot reverse everything. We cannot see the source code of malicious software, but we can always reverse this binary file into processor CPU instruction, into assembler. But to understand what is happening inside, we have to have people with such knowledge, right? So if someone is dealing with issues related, for example, to databases, in most cases, such people will have to be Oracle, Microsoft SQL, MySQL, PostgreSQL architects. So it's not just a common IT guy. It's a high skilled expert related to database. If we will deal with let's say network devices and infection or breaking some next generation firewall rules, when hackers do the bypass through the unified threat management, etc. In most cases, those people who will handle such events have to be experts in particular area, in particular vendor. So bypassing Palo Alto, bypassing FortiGate, bypassing SonicWall, Juniper require, from hackers' perspective, a huge knowledge about those platforms. And if someone is handling security incident related to this, he has to have also a huge knowledge about those systems architectures. And developing such team is also very expensive thing. That is the first step. The second step is set expectation. So we will have to communicate all the stakeholders, all our bosses, etc., all our departments, that we build a team, and we have to set up expectations, or we have to send the questions to those departments. What are their expectations to our team? How they would like to interact with us. We have to have already some kind of vision for all our company, and from that vision we have to build an incident handling and response team vision. Then we have to communicate this vision to everyone in our company, and before we will deal with an incident, we have to prepare our company to interact with incident handling response team. Our employees have to know what is the point of contact, to whom they can provide their credential, etc. So we have to have all those things written in the documents, like procedures, policies, etc. And of course, after announcement, after evaluating, after building everything, we have to introduce in our company regular checks, regular tests related to level of our incident and handling response effectiveness. So we have to score them somehow, because every company would like to see a progress in a knowledge, progress in a speed of taking care of some things, because when we close investigation in a 1 week, or when we are able to close investigation and recover in 2 days, these two scenarios will impact our costs. Yeah, so we have to deal with it. Anyway, here we can see the roles and responsibilities in the proper huge company, how it should look like. We should have an information security officer who is responsible for all teams in our departments. Yeah. In security department, we have to have managers related to incident handling. Then we have to have security analysts, incident coordinators, which are people responsible for coordinating any interaction with end user, with stakeholders, with CEO, CFO, so management staff in our company, etc. Many issues require approval from management staff. So incident handling response team discovers something, he has some suggestions what to do next, but in many cases he has to wait until someone from higher level approve the action. Yeah, so should we restart, or should we disable some services for some time? Should we remove some people from offices because one of them is insider threats or something like this? Those kind of actions, the decision for related to those kind of actions cannot be on the IT guy from incident handling response. Those kind of decision should fall down from the management level. So how to deal with forensics tasks, how to deal with discovering what was the goal of malware we discovered in our company. To deal with such things, we have to have people like forensic investigators, like threat researchers. And those kind of people are not system administrators, network administrators, internal auditors, financial auditors, etc. Yeah, so a lot of interaction here. And training and preparing personnel, I mentioned that is crucial. We should have sufficient number of employees to deal with everything. We should provide to them proper environment. So they have to have a lab environment where they can, for example, duplicate our production environment, at least in some part of our production environment, to test what was the intention of the malware. Yeah, and if our budget is too small to have experts on the board, we can always hire on demand some external experts. How to prepare the testbed, how to prepare such environment for analyzing malware. Here we are talking about creating at least few chip deep computers. What is chip deep computers? Is a computer which has a clear system without any issue. And on the system, we will install many tools to monitor system behavior, to monitor registry, to monitor services, running services, to monitor network connections, etc. And then we are going to put suspicious files inside that environment and run it, and we will watch what is going on with malicious code, what malicious code is doing with our system. We have to discover it. And one chip deep computer is not enough usually, because with one chip deep computer we are not able usually to discover the network vendor propagation. How is he doing that? So we will have to have at least a few chip deep computers in lab environment. That's why here we have suggestions to allocate physical system. It could be some powerful server, physical server. On that server, we will install hypervisor like VMware, Hyper-V, KVM, whatever you want. On that hypervisor, we will put some virtual machines. Yeah, so we will install inside virtual machines Clear OS. We can build even environment when we deal with Microsoft system, Linux system, Macintosh system to discover if our suspicious files is going to attack every platform. Yeah, and when we build such environment, we have to isolate this environment from the rest of company, from the rest of productions, and even isolate from network perspective. We have to isolate the traffic between virtual machines and between hypervisor. So malware, the goal is to make it impossible to jump out malware from virtual machine to hypervisor level. Yeah, so we can install tools like iNetSim. It's a software to simulate internet services, and then we will install those tools I mentioned before to monitor everything. We will generate the hash values of each most important part of our system, like binary files, like dynamic libraries, etc. Because we would like to have security posture of this system before any infection. Yeah, and then after malware will start, after malware is activated, we will observe every changes. We have to discover it, and we have three types of malware analysis. First, static, second, dynamic, and intrusion analysis. And what is the goal about each one? The static malware analysis, it's a kind of activity when we do not run malicious software. Yeah, we will try to analyze code, analyze many aspects of suspicious files without executing it. And we will generate checksums. We will use some kind of scanning, online scanning, local scanning. We can do some deassembling even on the lowest level and analyze the code itself without running it. When we talk about dynamic malware analysis, it is related to observe behavior of suspicious threat, suspicious files. We would like to discover if this malware is going to inject something into, for example, AutoStart, or inject something into registry, or is this malware going to change anything in our libraries, in our binary files, etc. That's the goal of dynamic malware analysis. We would like to discover here if any malware is going to connect to the internet, for example, to download the rest of malicious code. In many cases, the first initial infection is made by part of a malware called downloader. And this downloader usually do not have many dangerous instructions. So when we put such downloader for scanning, when you deal with this downloader with Asset Antivirus, Kaspersky, Symantec, Trend Micro, McAfee, etc., those kind of software can tell you that this is clear file. Why? Because there is no any dangerous instruction inside. But this kind of malware can download in a covered channel the real danger code, and we have to discover it before this software will be activated by any of our employees in any place in our infrastructure. That's the goal of dynamic malware analysis. And intrusion malware analysis, it involves analyzing information achieved from intrusion detection system, from unified threat management, from routers, firewalls, etc. So we will deal with, in most cases, with a log and with correlation of some events. That's how that is the way to detect malware in intrusion malware analysis. And some techniques used in static malware analysis are file fingerprinting, which is generating hash values and comparing it with values provided by vendors, for example. Local or online malware analysis, it's scanning by Symantec, Kaspersky, or by VirusTotal. We will see it in just a little bit. Performing string search. Well, in binary files, there are strings which are human readable. There are messages for interacting with user. Like probably some of you saw the message from software, this program cannot be run in DOS mode. Yeah, and in most cases, this kind of message is in the string inside binary file, and we can find it. So yeah, that's the performing search string. Tools to identify obfuscation method and packaging are also very useful, because intruders usually would like to hide their threats inside something which looks like okay. Yeah, and they are manipulating malicious code so in the way that no signature will fit to that manipulation. And this is this kind of hiding something dangerous in a way we cannot discover by default what is it, what is going to do. It's called obfuscation. So incident handlers and responders will deal with tools to detect obfuscation method. Some malware is deployed in as a portable environment, as a portable software, and we have the dedicated tools to deal with it. In static malware analysis, the researchers can also go into low-level analysis when they are try to identify file dependencies. which binary exe file is going to use which dynamic library, which function is included, what kind of functions are included in dynamic libraries, yeah. And the lowest level, possible level of dealing with malware is malware deassembly, and I mentioned about this before. So here we can see some example related to checking the hash. So file fingerprinting, I mentioned before, it's just computing the hash values from our files, and we can compare the values with the values from vendor side, or when we have an infected file and clear file, we can compare them in a strict way through this method. Searching searching strings in binary files. I mentioned about this before. So the tools like beantext we can use to discover such strings. Of course, when you see a string like this program cannot be run in DOS mode, it tells you nothing. But you can sometimes find the URL or FQDN included in malicious software. So you will discover where is going connection, probably where will go connection from this malware. And you can implement, for example, the rules, the policies on firewalls, web filters, etc., to block connections with those sources, yeah. And in this way, you will eliminate possibility to malware to download the rest pieces of malicious code. And if you, for example, find inside binary file the message that you have to pay some bitcoins to someone, then you will discover probably what is it. You will figure out what is it. Probably ransomware, right? What else? I mentioned about obfuscation. I mentioned about it as a way to hide the execution of some malicious instructions inside programs in the way that no antivirus is able to detect it. That's the goal. Of course, it's a challenge because hackers figure out a new method after a few days. The defensive teams in companies like Symantec, like Trend Micro, will implement solution for this to discover it, etc. So who's first? It's a ongoing process. And if we deal with our teams to detect those obfuscation method, they can use tools like PID to discover it. In dynamic malware analysis, we will execute the malware. We will observe behavior. And this approach can be done even if our employees do not have a programming language background. Because in this case, we will observe effects, yeah? We will discover effects. And when we build a environment to test it, I mentioned that we have to install many tools, like process monitoring tools to discover how the malicious software is going to embed in our memory. The port monitoring tools to discover the network traffic from malware. Registry monitoring tools to discover if malware is going to achieve persistence through registry, for example. Windows Service monitoring tools, startup programs monitorings, event log monitoring tools, etc., etc. So all those points we have here on slides and the previous slides are covered in curriculum, are covered in ECIH training with some suggestion what you can use. Sometimes EC Council point us to open software. Sometimes they suggest very expensive solutions you have to buy with license. But there are tools very powerful where you don't have to spend a lot of money. Like, for example, Process Explorer from Microsoft. This tool was created by Mark Rusinovich. He was enemy number one for Microsoft for some years. But it was like 20 few years ago. They have a case in the law court, Microsoft against Rusinovich even. But the case was closed because Microsoft figured out, well, why should we fight against such talented developer, such talented programmer? They just hire him and they just bought all sys internals. Right now, it is a crucial part of Microsoft tools, sys internals, and Mark Rusinovich is one of the chief in Azure department, I think, in Microsoft. So he's still working. He's like celebrity inside Microsoft. And this tool, Process Explorer, is like a task manager on steroids. So with this tool, we are able to discover where malicious software is going to hide, where connections are going from this thing. Well, maybe I will show you how it can look like, not on the slide, but for example, we will run it directly on my PC. With this PC, I am providing this session. So here are my processes. As you can see, we can, for example, see which kind of processes are hidden by SVH host exa service. Yeah, when we have some suspicious that, for example, this kind of tool is going to hurt us, we can check this tool in a VirusTotal webpage. I think that every one of you knows exactly VirusTotal webpage, when we can upload some file and check if it is, for example, let's go to some binary files, desktop, TCP View. Let's go check these binary files. It is okay or not. This kind of solution is going to scan with many scanning engines this file, uploaded file, and tell us if everything is okay. And we can see that no single antivirus detect any threat inside. Yeah. And when we deal with a lot of such things inside infected system, uploading next file, uploading next file, uploading next file is like a wasting of time. And this tool allows us, for example, to scan directly from here if this file is okay. And this tool is generating hash, sending hash to VirusTotal. If such file was already scanned, we can see score here. Zero detection on 71 scanning engines. Yeah. We can observe, for example, if this kind of tool service is going to hurt us in this way. We can also check, for example, properties and check if this particular service creating any session to anyone or listening on any port. If I had debugging tools from Microsoft, I could even debug memory over here. We can see the performance related to this particular process. Strings, we can find strings here, like here. This program cannot be run in DOS mode. We mentioned about such things before. We can observe threats, etc. So very, very powerful tool to analyze what is going on inside our system. And in the ECH course, you will have labs related with to such tools. The next things like TCP View. If we would like to discover what kind of session are going from our PC to anywhere, we can do it in many ways. Let's see the things built in every Microsoft system, and Linux also has the command like netstat. Yeah, and this tool netstat, and this tool shows me what kind of connection are already established. We can, with proper options, display every single part of network communication in our system. And we can even discover which process is responsible for a particular connection. But to run this, I should run before the command line with admin privileges. Yeah, we can see here that this things requires running CMD. Let's go with CMD and run it as an administrator. And right now, this tool netstat-inb is going to tell me which connection is which process is responsible for which connection. In some cases, we cannot obtain ownership information and we have to use other tools. But dealing with netstat is not efficient too much, and we have a beautiful tool from Mark Rusinovich called TCP View, and we can see here all the table right now, all the processes, process ID, local remote address. We can kill connections from here, like kill process. We can search for this particular file where it's located. We can go directly over there by clicking explore. So it is more useful and more nice tool than netstat, for example. And with TCP View, with carports or similar tools, you will have a lot of labs inside ECH course. Some of them are self-study. So at the end of my presentation, a few things about the lab environment related for ECIH. In ECIH course, as an outcome, we deliver usually environment from our hardware, from our cloud. And when the course is done, many people ask us, can I have an access to this lab for longer period? And to be honest, not always we are able to provide extended times. We had some exceptions, but usually the last day of training is the last day with access to our labs. So what you can do, you can always create your own lab in your own environment, but you can also buy iLabs from EC Council, and this is a service, subscription-based service, and with iLabs you have fully automated environment. So if you finish some lab and you start it again, you have initial conditions. So you can go through the lab once again and once again and once again. Until you master those options inside some tools. You have 24/7 access for 6 months. And as far as I remember, it costs about $199 bucks, dollars. So it's not too expensive, half of year accessing lab environment, and you don't have to be afraid about malicious software because you run it on the remote environment. Inside ECIH course, we have real threats to run, so real Trojans, real viruses. They are inside, and running it on your own PC, even in virtual machines, usually generate some questions to me as an instructor. Dominic, is this malware able to escape from virtual machine? Well, no one will give you SLA for malware. So from my experience, these tools will not go outside, will not going to escape from virtual machines, but I cannot guarantee it. So you have to take it on your chest. My suggestion is to have a dedicated PC with, for example, software like VMware Workstation and inside virtual machines. And even if any malware is able to escape from virtual machine to the system host, if it is isolated from your environment and if it is dedicated only for labs, nothing wrong will happen to you. But when you deal with iLabs in a EC Council cloud, you have a simple solution without any threat to you. And this tool has also safe step technology, which means if you have some long lab with many steps, and right now it's 20 after 10 p.m. and you are going to sleep, you can save your progress and continue your lab tomorrow. You can also skip the safe state steps, and then you will have to next day repeat all steps from the beginning. Yeah, so very, very nice things. And I'd like to show you a real demo from iLabs, how it looks like, not only on slides. So I am going to switch from my presentation to environment when I have a lab. I started this lab before I delivered the speech, and your lab time has expired. So right now I am going to run it once again, but I am afraid I will have to wait a few minutes until up to 60 minutes until the lab will load. So maybe before this lab will load, any question, I will switch to our presentation. I will turn off sharing screen right now. Do you have a lab about difference between Process Explorer and Process Hackers? Well, Process Explorer is for sure in labs. I don't remember. Process Hacker is mentioned for sure in the slides, but I don't remember right now. Is there a lab dedicated to Process Hacker? There are tools automating things like Cisco Malware Analytics, CrowdStrike, etc. Yeah, there are many tools outside, but this training is like vendor independent. That's why we don't have any dedicated licenses for delivering, for example, such platform to students. And in the curriculum, you will have some description related to such tools, but we don't have a control panel for Cisco or something like this. If we would like to have a course with such tools, we have to calculate license cost for every student, and this kind of course would not be like $1,000, but $20,000. Yeah, so unfortunately, in most cases, we deal with open source or trial version of some software. The question was, shouldn't we start with a risk assessment? Yes, and it is mentioned in the first module of ECIH course. I will check if our labs already started. Yeah, already started lab. So I just ran right now module 4, handling and responding to malware incidents. We have a limited time for this lab, but if I will not fit in this time, I can run it again, or I can choose which exercise I am going to go through. Exercise 1 is related to TCP IP connections using carports, and you can see step-by-step instruction over here. So if you buy an iLabs, you don't have to open curriculum with lab content, because this lab content is also included here. Yeah, so you have some lab scenario, you have some lab objectives, and every single step you have over here. Click on Windows 10, so we will switch to Windows 10 virtual machine. Click Control-Alt-Delete. You can provide password by yourself, or you can, for example, click here. You can log in. Then how to navigate to which folder, how to open anything. In this lab, for example, you will create the Trojan with ngRat software, and you will deliver the malicious agent to victim station. You will observe communication, and the next thing will be, for example, observing with carports software connections from your Trojan and kill the sessions, for example. Yeah, that's the first lab. The second lab is a registry entry monitoring with dedicated tools. So the next lab is, for example, performing startup program monitoring. Yeah, the next lab is device driver monitoring, step by step, with tools like, for example, Driver River. And the next is detecting Trojans with port monitoring, process monitoring, registry monitoring tools, and some tasks have for example 10, 11 steps. Some tasks in some labs have up to 100 steps. So depends on tool, depends on scope of particular exercise. The virus analyzing tools using virus total. You will also have labs related to going deep dive into virus analysis through the IDA software, like watching how malware is built and watching what is the code, assembler code inside. So it's deep dive tool. Of course, in this training, we will not cover what is assembler, how it works, etc. If you would like to go to such subjects, you have to find dedicated courses, dedicated trainings. It could be a few years development to deal with software on assembler level, yeah. And you have to do it on your own in 3 days. No course is able to deliver such knowledge, yeah. OLEDBG, it is also a lot like how to run it, how to open some things, but we don't have here explanation what this particular command means, why jump to this registry, to these sections will do something. It just, in this course, we have a cross view through the many tools, how they work, what you can use. But if you want to have people in team related to deep malware analysis, you will have to find people with a programming background. Yeah, in CH courses, in incident handling courses, so far from my observation, 80 few % of attendees do not have a programming developer background. Yeah, so maybe some kind of Delphi, C# or something like this from university level from few years in the past. They have some basics, but in most cases they are not familiar with assembler, for example. So the next lab is like removing malware with a ClamWin, antivirus, etc. This kind of things are included, but this is only one module, and we have a few 9. As far as I remember, there is 9 modules included in 3 days, and most of these labs you will have to do on your own in the evening, or by building your own lab environment, or by buying access to iLabs. So we have introduction to incident response handling, and in this module we cover the risk managing, and there is also inside this module there is also lab related to risk managing with a proper tool. It's called Pillar. Wow. I cannot run it right now in a new lab. Why? Okay. Another lab is currently active. Okay, I will not show it you right now because my time is up. My time is done, dedicated for this delivery. But there is a Pillar software which helps risk management teams to manage risk in proper manner. In the next module is incident handling and response process. Then the next one is forensic readiness and first response. And those three first modules are in majority of content about setting some rules, setting some steps, not too technical. But when you go from module 4 to 9, this is rather technical approach, because we talk about malware incidents, email security incidents, network security, handling problems, issues with cloud security incidents. In module 8, we don't have any lab, so it would be hard to deliver labs here, because every student have to provide, for example, credit card numbers to buy, for example, Amazon Web Services subscription, etc. We do not require such things, but Module 8 do not have any labs. And the last one is dealing with insider threats, so dealing with people. That's how it looks like, and that was my part of delivery. And the next one will be Tomasz.